Okay, good afternoon, everybody. I am Paul Quinn, Network Manager of Industry 4 SkillNet, promoted by Futurecast. I'd like to welcome you all to our second in our webinar series, Industry 4 and the Digital Transformation. This week, we'll continue our exploration through the pillars of Industry 4 and how Irish SMEs can use it to good effect and good use of case studies. Later on, we'll have a special guest expert, James Cobot from SimVirtua. James will talk us through his presentation of augmented reality in manufacturing. So everyone's seen the Pokemon Go game on phones a few years ago. It's perhaps their first knowledge of augmented reality. Now, Currys have an app, and also IKEA, where you can use augmented reality in your home. So, right, I'm going to hand you over shortly to our host, Billy Schofield, who will take you through the rest of the day. I hope you all enjoy the day, and or if you could fill in the feedback forms to give us a bit more information and how we can improve, that'd be appreciated. Okay, thanks everybody, and hello Billy, how are you doing?
Thanks Paul. I'm sorry about the eye patch. I've not turned into a pirate. I had some minor surgery in the earlier part of this week, so I've got a little bit of an issue with my right eye just now, but all good. So I'm just going to share my screen. So what is Industry 4.0 and the digital transformation? My name is Billy Schofield, and I've worked in advanced manufacturing for the last 37 years. And I'm going to share with you some of the things I have learned about advanced manufacturing. So thank you to Paul and the SkillNet team for inviting me to talk with you today. And thank you for attending this webinar 2 of the Industry 4.0 and Digital Transformation webinar series. At the end of this webinar series, you should have a better understanding of the Industry 4.0 concept and how to apply it in your setting. So this is webinar 2 of a series of 4. These webinars run each Thursday at 1:30 p.m. Irish time. So the webinar series is Introduction to Industry 4.0 and the Digital Transformation, a series of 4 webinars. So in webinar 1 last week, we covered the Introduction to Industry 4.0. We had a look at its origins in Germany in 2011 and some of its key concepts. We spoke about the smart factory and cyber physical systems, 2 of the core concepts of the Industry 4.0 initiative. And last week, our guest speaker was Dr. Ali from IT Sligo, who gave us insights into some of the training that IT Sligo offer on the industrial Internet of Things and Industry 4.0. And I can vouch that both those classes that IT Sligo offer are excellent. I've attended both and I learned a great deal from them. So webinar 1 completed last week. Webinar 2 today, we'll be looking at decentralized decision making. How do we make decisions quicker in the Industry 4.0 setting? How do we enable our employees to make decisions quicker when they have more information available to them? We'll talk about cobots, collaborative robots. These are robots which collaborate with their human operators to achieve tasks. They're not behind some metal cage. They're in the same workspace as their human operator. Then we'll speak about the concept of digital twins, which is one of the tools in our Industry 4.0 toolbox. Then today, our guest speaker is James Corbett from SimVirtua Limited, who'll talk to us about augmented and virtual reality. So James will give us a short talk on augmented and virtual reality, And I think Paul has some questions for James. Then we'll open up to the chat box any questions you might have for James on AR and VR. And James will be joining us round about 2:15. Webinar 3 next week, we'll talk about cybersecurity, additive manufacturing, big data and data analytics. And our guest speaker in webinar 3 will be Ian Keeney from Skellig AI. So really excited to have Ian in to talk about artificial intelligence and how it's impacting industry now. It's become so much more affordable, and artificial intelligence, and Ian can share us how companies are accessing artificial intelligence systems. It's came a long way since the response flow charts and expert systems that I was using back in the 80s and 90s. Then the final of our series of 4, webinar 4, we'll look at future trends. What's coming? What will things look like by 2030? We'll start to discover how to build our own roadmap for Industry 4.0 implementation. And our guest speaker in webinar 4 will be Brian Cooney from KUKA Robotics. So he can give us real insights into what's happening in industry in the use of robots, automation, and cobots, which I'm going to introduce you to the topic today. But Brian will do a deep dive for us in webinar 4 and show us some real life examples from industry. So for those that missed webinar 1 last week, it is on Industry 4.0 SkillNet's YouTube channel. You can see it on, you can view it on the SkillNet channel at Industry 4.0 SkillNet. I've put the link there to the webinar, and the full webinar is there for you to view if you missed it or if you want to view it again. And after today, we'll post today's webinar up there with it as all, so that at the end of the 4 series, you have access to all 4 webinars. And if you missed last week, I'll just reintroduce myself. My name is Billy Schofield. I'm a trainer. I have a master's in management of operations from Dublin City University, where I wrote my thesis on the readiness of Irish manufacturing companies for Industry 4.0. And I have a degree in applied physics from the University of Strathclyde. I spent 13 years working at Motorola in Scotland, introducing SPC and Six Sigma into the Motorola factories in the 1980s. And I spent 19 years at Intel Ireland in various engineering manager positions. I've worked for design and planning services in Ireland, and I was a senior process improvement advisor to the Royal College of Surgeons in Ireland. And I provide part-time lecturing to Dublin City University on numerous topics. So our agenda today, we'll be doing our introduction. We'll be talking about cobots. I'll introduce the concept of cobots, collaborative robots, to you. We'll talk about decentralized decision-making, an important part of the Industry 4.0 initiative and one that's often overlooked. Digital twins, one of the tools in our toolkit. And our guest speaker will be talking to us about augmented and virtual reality, Mr. James Corbett. He'll be joining us just after 2 o'clock. Again, this week we will be doing another Mentimeter survey, completely voluntary. If you don't want to take part in it, that's fine. And all the information is anonymous. So do have a tab open on your smartphone or on your laptop at www.menti.com. And when the time comes, I'll supply you with a code to participate in this survey. So just a little survey to gather a little bit of data and have a little bit of fun today. So make sure you've got a tab open at www.menti.com on either your smartphone or your laptop. I'll give you a code when we get to the time to participate in the survey. and again, completely voluntary. So last week, we spoke about the 4 industrial revolutions and their impacts on society and life on planet Earth. And we looked at how they had impacted world GDP and the origin life expectancy over the last 200 years. And we've seen exponential increases in world GDP and life expectancy through the 4 industrial revolutions. So all an industrial revolution is a period of intense the application of scientific advancement into industry. And we spoke about last week about the first industrial revolution in the 1790s with the introduction of mechanized factories run on water and steam. We've seen the second industrial revolution in the 1870s with the electrification of society and of industry, and the introduction of a conveyor belt process flow technology into factories, especially in the meat processing factories in Cincinnati and Chicago. Then we spoke about the third industrial revolution, the digital revolution. It was the introduction of sophisticated integrated circuits into manufacturing, allowing for much more sophisticated control systems. And these sophisticated circuits are based on transistors, billions of transistors on an integrated circuit. Transistors can either be on or off, a 1 or 0, hence the term digital. And through a form of algebra called Boolean algebra, we can do the mathematics of computing. And we reflected last week on how Boolean algebra had been founded here in University Cork, Dublin in 1870 by George Boole. So the digital revolution in many ways began here in Ireland in the 1870s. Then lastly, we came and we discussed the 4th industrial revolution. It began in Germany in 2011 as a program generated by the German government to readiness and improve the German manufacturing for the demands of the future. And the key to that industrial revolution was the application of internet technologies into manufacturing facilities. How do we gather the data from all our tools and equipment in our factory and transfer it into our IT databases using the internet? So we looked at the impacts, the other impacts of the industrial revolutions. We've seen that the population of the world in that period has risen from 1 billion people back in 1800 to 8 billion people today, and is expected to reach 11 billion by the end of this century and stabilize at that. We've seen one of the other impacts of the industrial revolutions is the increase in fossil fuels that we've been using, both coal, oil and gas, and those show no sign of decreasing. So a huge consumption of fossil fuels driven by the 4 industrial revolutions. And the impact of that from releasing all that greenhouse gas into the atmosphere is that the temperature of the planet has been increasing through that time period also, which is one of the biggest challenges that we face today in society and scientifically. Then we done some work last week on our whiteboard, and you gave me some other impacts of the industrial revolutions. And we spoke about how it increased the number of jobs that there are, how healthcare had improved. You recognized the impact on climate change, on consumer choice, and on globalization. So that was some of your work last week on our whiteboard. So the 4th industrial revolution began in 2011, and we looked at some of the key concepts of it last week. We spoke about the connected factory, a factory that gathers and harvests data from its equipment and tools using sensors, transfers that data into our IT databases, where we can then do statistical process control, generate dashboards, We can apply artificial intelligence to that data to help us make decisions. We spoke about cyber physical systems, where systems where a computer program or a computer algorithm controls a physical entity. And today we'll talk about decentralized decisions and cobots. And of course, all of this is about improving productivity and efficiency, about achieving more but consuming less resources. That's what's key to Industry 4.0. So there's a huge overlap between Industry 4.0 and lean initiatives, which we are already running in many of our factories, and our green sustainability initiatives, which are also about being more efficient in consuming less resources. Aligned with the Industry 4.0 initiative is also 3D printing, which we'll come to in a later webinar, artificial intelligence, and the rise of autonomous systems. Each year our cars become more and more autonomous. And last week we did speak about quantum computing, a new type of computing that's will be emerging and we will have access to on the cloud. So basically we're into 10 years of the Industrial Revolution, the fourth Industrial Revolution, running from 2011 to 2021. And the digital transformation never stops because there's always new advances in science coming that we're able to apply to industry and keep driving the industrial revolutions and the digital transformation forward. So the Industry 4.0 factory, we spoke about the concept last week. At the base of it is the smart or connected factory, the factory that gathers its information and data from its equipment using sensors, transfers that data into our IT databases. On the columns of our factory are cyber physical systems, those systems where we have software controlling physical processes in our factory. And today we'll look at cobots, collaborative robots, robots that are assisting humans to achieve tasks. And we'll talk today about the fourth key concept of the Industry 4.0 initiative, and that's the area of decentralized decision making, employee empowerment, often overlooked, but as we make more information and data available to our employees, we need to empower them to make decisions and make decisions quicker. So within our Industry 4.0 factory, we have many tools, such as digital twins, which we'll touch on today, augmented reality, which we'll have a guest speaker on today, cybersecurity we'll talk about next week, 3D printing, data analytics, and artificial intelligence, all of which we'll touch on in the next two webinars. So last week we did do a poll, a Mentimeter poll, and you were asked the question, in your opinion, what Industry 4.0 areas is your company focusing on? And the three top areas that we polled last week at was data analytics, the smart factory, and cybersecurity. So these were the three most important items to the team who voted last week. And when we compared that to earlier polls I had done earlier this year and back in 2018 when I had done a more extensive study of Irish manufacturing, we found that these were very similar. You know, data analytics is always coming out the top. So it's really important to recognize that, you know, Irish manufacturing companies are looking at how to improve their data analytic capabilities and introduce smart factory capabilities. Cybersecurity has come up the Pareto recently in recent months, really with the huge scares that we've seen in our healthcare industries here in Ireland with a big hack of the system. So cybersecurity and protecting our intellectual property has become more important and moved up the Pareto in recent surveys. So last week we did do some whiteboard work, and we'll do some whiteboard work today as well. Last week we recognized what the 4 industrial revolutions were, the impact of the 4 industrial revolutions. We discussed what is digital, and we had looked for examples of cyber physical systems that we have that we see in our factories and in our lives. Alexa being a great example of cyber physical system that we all interact today with, that we would have seemed like science fiction to us 10 years ago. And then the Industry 4.0 focus areas that we identified in our survey with you last week, which was data analytics, the smart factory, and cyber security. So last week I did give you a call to action, optional of course, but well worth considering. I asked you to assess your organization for its adoption of the smart factory and cyber physical systems. You know, have a look about in your factories, in your operations. Do you have smart factory and cyber physical systems already there in some pockets of it? You know, list them down, recognize where you're at in your journey. Then think about, are there other high cost areas in your factory or in your operation where they could be applied, or CPS or smart factory concepts could be applied? And find out what your competitors are doing. So hopefully some of you have started to think about this. You know, what CPS, what smart factory examples you have today, where else could they be applied, especially in high cost areas in your operation, and start to research what are your competitors doing. And it's by writing these things down, articulating them and sharing them with each other that the real thinking begins. So don't just jot them down and put them away in a drawer. Start sharing these ideas with other people in your organization. That's when the real thinking begins. So today I wanted to talk a little bit about one of the third key concept of Industry 4.0, and that's cobots, collaborative robots. So cobots are robots designed to cooperatively assist their human operators. You know, the machines are there to help the human beings, not the human beings are not there to be the servant of the machine. So the Industry 4.0 concept is designing cobots that they help their human operators. And they're not locked away behind some cage, but they can work in the same physical space as their human operator. And I took this example from Boston Consulting Group, who showed this example of a cobot. So here we have in the example, you know, a worker lifts the roof lining into the car and it's difficult to handle. They're having to put it in there. The worker manually aligns the roof lining and holds it in place. Then the worker has to fasten the roof lining with screws and requires them getting into some uncomfortable ergonomic positions to do that. So quite a difficult task for the worker. When we introduce a cobot to assist the worker working alongside our automotive worker here, the robot lifts the roof lining and places it in the chassis. The worker guides the robot in aligning the roof lining, but carries no weight. And lastly, the robot fastens the lining with screws as directed by the worker, who maintains a comfortable position. So this is an example of a cobot, a collaborative robot, a robot that's working with a human being, assisting the human being to achieve a task. And we're seeing more and more cobots arrive in industry and be available to us. And when we get to webinar 4, we will have a look at KUKA Robotics. Will share some examples of cobots that are in use in the world and in industries in Ireland. Now, it was in 2017 I started working for the Royal College of Surgeons that I was really impacted by what was happening with cobots in surgery. And I'm sharing this example because it really shows for you what is possible. So in 2017, I started working as a process improvement advisor to the Royal College of Surgeons. And that's when I came across something that I had been unaware of, and it was the use of cobots in surgery. So this system we see here is a Da Vinci cobotic surgery system. In fact, one of these was installed into University Hospital Limerick way back in 2016. So they've been about for a long time. And here are the cobot and the surgeon can collaborate together to perform the surgery on the patient. So the surgeon can sit at this remote control panel and the cobot can actually perform the surgery. And of course, the great thing about this is that the surgeon doesn't even have to be in the same room as the patient, doesn't even have to be in the same town as the patient, and ultimately doesn't even have to be in the same continent as the patient. Surgery can now be performed remotely with the cobot and the surgeon collaborating. Now, there are over 4,400 Da Vinci systems installed in hospitals worldwide today. So it's a very common system and has a huge impact in the healthcare world. Some 43,000 surgeons are already trained on the use of Da Vinci, with over 7 million procedures having been performed. And if you look into the press, you'll see that in the UK, the National Health Service there has heavily invested in another cobotic surgery system called Versius. And they're installing many of these Versius systems into hospitals in the NHS network in the UK. So cobots are real in the world of surgery, something that we would have thought was certainly the world of science fiction. So you might just want to reflect for a moment how you'd feel about going into surgery and having one of these Da Vinci or Versius systems operate on you. Some of you may already had experience of these systems. Unfortunately, my eye surgery this week was done by a human being without the assistance of a cobot, but maybe that will change in the near future. And one other system I want to talk about is STAR, another cobotic system. So here's just some pictures of Da Vinci in action. You can see here this is some colon surgery via a 2.5 centimeter incision at the belly button, performed by a Da Vinci Xi collaborating with a surgeon. And these pictures were from September 2018. So one of the things about this is the incision size can be very, very small, which is great from a infection reduction point of view. So the best surgeon in the world is STAR. That's official. So this is STAR. And this paper was published way back in 2016, so 5 years now ago. So STAR is a smart tissue autonomous robot. And this paper concluded that we demonstrate that the outcomes of supervised autonomous procedures is superior to surgery performed by expert surgeons. So in fact, the best surgeon in the world is a robot, a STAR, an autonomous supervised robot. Now, to be fair, the procedures that this robot was doing were relatively simple. They were stitching wounds and closing wounds, so relatively simple surgery, but they could do it to a higher degree of skill than a human surgeon. So in webinar 4, we will look at how cobots are being used in manufacturing when KUKA are in. But I just thought that the whole story around the use of cobots in surgery just lets us know what is possible. That's something that we would have thought was really, really, at the top end of the capabilities of robots is surgery on human beings. And it's real. We've seen already 7 million procedures in the world conducted by cobots in surgery. So maybe I'll switch to my whiteboard, and maybe some of you might already have seen cobots out there, and you can maybe give me examples of cobots that you've seen. So I'll stop sharing, and if in chat you can start entering cobots that you have that you've came across. So Paul, if you could help me out here and you can call out anything that's coming into chat, I'll just switch off my background so you can see my whiteboard. And maybe if you could make me big, the main screen as well, Dara. So Dara, if you can call out, sorry, I might have said Paul there.
Yeah, so we have lots coming into the chat now, Billy.
So I'll capture a few. So we're looking for examples that people have seen of cobots, and I'll just capture them on our whiteboard.
So we have assembly, packaging, and production lines.
Assembly, packaging, yeah.
And I suppose the main one these days is car factories.
Car, yeah, automotive industry, yeah. You know, the automotive industry has had the big bucks for a long time. So when you look at automotive, avionics, and the semiconductor industry, they've kind of have been leaders in many of the application of these systems just because they've had the money. But these systems are becoming more affordable to us all the time, and we'll see that on in webinar 4.
Yeah, an interesting one, IAM Robotics, I think it is, the shelf-picking mobot or robot.
IAM robots.
Then we also have, I don't know if this is an example now, Billy, an autonomous car. Would that be classified as a cobot?
I guess it is. It's a good example. I hadn't actually thought of it like that, but that is a really great example. You know, the human and the robotic system that we have in the vehicle are beginning to drive the car. So that's actually a great example that I had never actually thought of. Autonomous or semi-autonomous cars, yeah.
And the sorters in the Amazon warehouses.
Oh yeah, those I've seen those videos of those sorters. And maybe one more, Dara.
Yeah. Palletizing robots.
Pallets, yeah. Palletizing robots, yeah.
Billy, I'd like to perhaps we should point out the difference between a cobot and a robot. That some of those applications you have there are robots which are behind fences. So a cobot to me should be something that can actually interact with a human. It's not swinging around at speed. It's not dangerous. It doesn't have to be behind a fence. So these palletizing robots are behind a fence. So for me, that's not a cobot.
Okay. So, but people are seeing real examples anyway of cobots, of systems where they have a robot and a human being working in the same space. Actually, the car is a great example I hadn't even thought of. You know, your car is a kind of a cobot now. We've got assembly systems and assembly packaging, the automotive industry, IAM robots, cars, Amazon sorters. And I don't know much about palletizing robots. I would have to look to see what was actually happening in that world. So some great examples there. So people are seeing cobots being used within various types of industries. So I'll just switch back to my screen. So I'm just going to share my screen again, and we'll move back to my PowerPoint. So we managed to gather some examples of cobots that you have seen in industry, and we've got quite a few there. So the second area I wanted to talk about today was the area of decentralized self-organization. So this is the final of the 4 concepts that I have for Industry 4.0, and it sits on the roof of our Industry 4.0 factory, covering everything. And it's often overlooked and often put aside and not thought about. So Kagerman, who helped put together the original Industry 4.0 concept for the for the German government. He, when he published his paper in 2013, he anticipated that the introduction of Industry 4.0 in the workplace would mandate a high degree of self-regulated autonomy with decentralized leadership and management process approaches. So at core to the Industry 4.0 concept wasn't just all this new science and engineering we were introducing into factories, but was new management processes and decentralized leadership where employees would have more autonomy. So Kagerman had noted at that time, employees should have greater freedom to make their own decisions, become more actively engaged, and have better control over their workload. That was a vision that he set for the Industry 4.0 initiative. So of course, this all fills into the area of leadership and employee empowerment. So the main point I would make here is don't think of your leadership and employee empowerment programs as something separate, as something that HR need to do or something that we'll do on a leadership training course. Think of it as an integral part of your Industry 4.0 initiative. How do we empower employees to be more autonomous, to make more decisions as we give them more and more information and more data, as we have more and more sophisticated systems available in our factories through artificial intelligence, statistical process control, dashboards, and better data analytics. Now I'm going to give you an example of not decentralized decision making. And I've seen this happen in really, and even in very, very advanced companies, you know, where they have many of the smart factory systems already in place, but they still stick to this decision-making process. So the technician on the factory floor has a problem. The system dictates that they need to call their engineer. They can't make the decision themselves. The engineer has to call the engineering leader. The engineering leader has to consult with his manager. The area manager has to consult with the overall engineering manager. The engineering manager has to talk to the factory manager. And the factory manager has to go and phone the corporate management before a decision can be made. And I've seen real examples of that happening in sophisticated factories, where a decision that needs to be made at the factory floor level has to actually go all the way through the hierarchy. And that's not decentralized decision making. So we should be trying to move away from that type of decision making because it's slow. It can be difficult to move information up the hierarchy. You know, what the technician here sees on the floor, it can be difficult to get that information all the way up the hierarchy. And it can be difficult to move information down the hierarchy. Last week, I was talking to a senior executive at a multinational, and she was telling me how she was visiting one of her factories, and she made a simple comment about, you know, oh, that could be better, you know, just like a passing comment that could be better. And she came back a few weeks later and found out that this factory had spent a huge amount of effort and resources on fixing this problem, based on this comment she made. And that wasn't her strategic decision. You know, it wasn't part of the strategic plan of the company to spend all this resources fixing this problem. It was just based on her simple comment. So moving information down could be difficult as well. And she certainly said she learnt the lesson about being very careful about what she says when she visits factories. But, you know, hierarchies have served as well, and we shouldn't just say that they're rubbish and they don't work, because they've served as well. And some of the most successful companies in the world have worked off hierarchies. But as we move into Industry 4.0 setting, we should creatively consider how to adapt them in an Industry 4.0 setting as we make more information available, especially at the shop floor, to the technicians working on the floor. How do we enable the technicians to make more decisions by themselves without having to go through this hierarchical consultation process. Now, it's about getting autonomy for employees. It's about personal independence and the capacity to make decisions and act on them. It's about us setting ownership and accountability. I remember working in a factory where I would be paged almost every night by technicians asking me questions that they knew the answer to. And that's because we had failed to set ownership and accountability. So the only way they felt the decision could be made was by calling me, even though they knew the answer to the question. So we do need to set ownership and accountability. We need to have mutually agreed goals and boundaries, and we need to coach rather than direct. And lastly, we need to delegate responsibilities to our team. And delegation is great because it enables people to expand their capabilities, and we can get more done when we can delegate responsibilities. So for employees, as you roll out an Industry 4.0 program, one of the questions you need to ask is, does this person have the appropriate level of independence and decision making? And it's something we should be constantly working on, especially in the Industry 4.0 setting. And it should be an integral part of an Industry 4.0 program. And many companies often forget that. So let's go back to our whiteboard again, and maybe I can get some examples from you. And how can we empower employees? What can we do to empower employees? So I'll stop sharing here and I'll go back to my whiteboard. So again, if you put into chat, how can we empower employees? What type of things can we do? And I'll capture them on our whiteboard. And Dara, again, if you can help me out and read out anything that comes into chat.
Yeah, we have Christopher here is straight off the mark with a few of them. One of his top ones is procedures.
Yeah, procedures documentation. Often we fail employees because we don't have good documentation. We don't have set procedures on how to deal with situations. So that's a great way to empower employees is give them procedures on how to deal with a certain situation.
Another one is defining escalations. And I suppose what that might mean is how someone would escalate something if they weren't comfortable with the autonomy, making an autonomous decision.
Yeah, people should be able to escalate, and they should know when, and should feel that they are able to escalate when they think, I really do need help with this decision. So they shouldn't feel as if, oh my goodness, I need to make this decision by myself. No, escalation is available to them. So those escalation procedures need to be defined.
Another one here, John says, providing resources to your employees.
Yep, resources. And I guess resources could be training, systems, access to all that information and data and how to interpret it.
Yeah, and also to let them make decisions in real time.
Yeah, real-time decisions. And that's really important. Because we want decisions to happen fast in our factories. We don't want things to slow down and to have to go through hierarchical systems to get a fast decision on the shop floor.
And two more that are quite linked here, Billy. So taking the initiative is to be encouraged, and also to encourage open communication.
Yeah, taking the initiative and open communication is really critical. And giving employees the systems and processes to do that open communication with, so they can share information and they can be communicated from their management teams in a very clear and crisp way. So they're great examples of how we can deal with employee empowerment. And I've put this section in today because it really cannot be ignored. It's a critical part of our Industry 4.0 initiative. So let me just share my screen again. So I did like this sketch note on you know, how do we engage talent in our factories? Just because for me it summarised a lot of the things that we were talking about there. So I put this sketch note in. You know, it's about, you know, work design, which we spoke about there, and we captured some of our bullet points on our whiteboard. You know, clarifying purpose, showing people how to contribute. It's about learning, you know, giving people the training, encouraging training, you know, from traditional training to on-demand training, looking at different ways of supplying employees with training. It's about alignment and clarity, you know, defining what it is they need to do, what does success look like, investing in the relationships with employees, you know, facilitating conversations with employees, and just creating that ecosystem for a high performance environment, you know, building trust, respect for people, which is core to many of our lean initiatives as well, and, you know, allowing a communication network that allows for collaboration and performance. You know, so I guess we captured many of these aspects on our whiteboard. So I think that we know some of the things we need to do to encourage employee engagement and empowerment. And we need to make sure that we're considering that as we as we change things in our factories with our Industry 4.0 initiative. Do we need to change our systems to support our employees to help them make decisions? So the third area I'd like to talk about today is digital twins. So this is one of the tools in our toolbox in our Industry 4.0 factory, the digital twin. So again, I'll go back to my whiteboard. So anybody, any idea what a digital twin is? You put it into chat again. What is a digital twin? And Dara, you can help me out again. If we get some inputs in there and what a digital twin is.
So it is a digital representation of a machine or process.
So yeah, digital rep of a machine or process. Yep, it's a great definition.
Yeah, simulation, I suppose, is a good word.
Yep, that's a great word for it. Simulation.
Our own Paul Quinn mentions the BIM models.
BIMs, yep, building information management, I think it stands for, doesn't it?
And real-time assembly line updated on a dashboard.
Yeah,
is that accurate, Billy?
Yep, real-time dashboard data, yep.
Liam says it's often created using laser scans of an assembled part.
Yep, laser scans. We can take that allows us to create a physical, a 3D image of the object by using scanning it with lasers, so we can have a 3D image of the object. Yep.
Yeah. And Gus adds that it's useful for process simulation, forecasting, and a test platform before going on to the real scenario.
Yeah, that's great. Simulations and a test platform. So it looks like there's a good understanding out there of what actually a digital twin is. So that's great. So I'll go back to my slides and I'll go through a few slides on digital twins. Sorry, every time I stand up, I nearly fall over my one eye. So we got some great examples of digital twins there, and there's a good firm understanding out there of what a digital twin is. So because digital twins, the concept really began with NASA back in the 1970s when they had physical twins. And the most famous example was the Apollo 13 mission in 1970, the failed Apollo 13 mission, which did not land on the moon. The service module had problems with an explosion, and the crew had to transfer from the command module into the lunar module, which had not yet landed on the moon. So you had 3 men had to survive for 4 days in the lunar module, a system that was designed for 2 men to survive for 3 days in. So NASA had to figure out how these astronauts could survive those 4 days in the lunar module and travel back to Earth. And they done that by they had physical replicas of the lunar service and command modules, so they could physically know exactly what resources the astronauts had available, exactly what constraints they had on them physically, and they could then work out solutions. And the biggest problem they had was how to absorb carbon dioxide in the lunar module with 3 men in it. How do you absorb it? They couldn't take the system from the service module because it was a different type of system. So they had to retrofit it into the lunar module. And they'd done that by having these physical models. And at the weekend there, I watched the movie The Martian, and I guess it gave a nod to these physical models. In the movie The Martian, the astronaut has to make an epic journey in his Mars mobile across the Martian landscape, and he has to retrofit his vehicle. And again, we see footage in the movie of a physical model back at the NASA base, working out how to retrofit the machine to make the journey across the Martian landscape. I think it was a bit of a nod towards the Apollo 13 mission. So the concept of having a twin was generated by NASA as a physical model in the 1970s. So you guys have correctly identified that a digital twin is modeling a physical object virtually. It's what we call a digital twin. That can be either data from the object, the physical size of the object by laser scanning it, or it can be both. So a digital twin represents a digital replica of a physical entity. So NASA first described the idea of a digital twin in 2011 as a complex flight simulation model. Digital twins are now considered part of the simulation-based systems engineering, as again you identified. One practical application of NASA's digital twin model is the practice of conducting virtual missions before the actual flight launch. So we've seen that, we spoke about that on the whiteboard. We can do simulations before we do the actual launch. So Edison said, I have not failed, I've just found 10,000 ways that don't work. But with a simulation model and a digital twin, we can test out all those different scenarios before we commit to the real situation. So digital twins can be used in design, they can be used for simulation, they can be used in fabrication, and product operation, and we can use digital twins to put through our Deming PDSA plan, do, study, adjust cycle to make improvements based on our digital model and not actually on the physical real system. And I've seen some pretty impressive digital twins of really complex equipment being used in its installation and de-installation. Having a physical model, having a digital twin was really essential to enable faster installation of the equipment and faster de-installation of equipment. And in the fabrication and operational setting, we can take data from our physical, true physical systems and feed that into our digital twin so that we have real-time data from it. And again, we've seen examples of that in our whiteboard discussion. So in design, digital twins are used in the automotive industry to reduce the concept to production time. So, you know, they go from vehicle concept to production, and they can, by producing the vehicle as a digital twin. It allows them to do simulations on proposed vehicles, and it allows for the development of autonomous functions as well, to help find that optimum solution by putting it through the PDSA, plan, do, study, adjust cycle multiple times before you have an actual physical car to work with. Digital twins can be used in product fabrication as well. We've spoke in depth about the smart factory last week. So we can use data from the smart factory to digitally twin the production process. We can use the smart factory to digitally twin specific production tools and assets. You've seen that. And that can help us do predictive maintenance on tools and assets in our factory by having that digital twin. And actually, we can digitally twin whole networks of factories. You know, we can look at, we can have 3 factories networked as a digital twin, and we can see what happens when we adjust the capacity of the factories, or we increase the inventory of the factories, and we can model that in our simulation as a digital twin of the network of factories. And we can do digital twins in a product operation. You know, if we take the example of our car, we can have real-time data fed to a supervisory digital twin, a digital twin of our vehicle. That then the car manufacturer can then diagnose when issues are happening in our car. The data has been uploaded from our car continuously, you know, which could be very specific to our own peculiar driving style. And then they can predict their predictive capability on what's going to happen with this car, when's it going to need maintenance, and so forth. So we can digitally twin real products that are out there in the market that we're actually using. So they're all examples of digital twins. And you'll come across the term the digital thread as well. So the digital thread is when we have a real object, then we have our digital twin. The terminology used for that data transfer between the real object and the digital twin is often referred to as the digital thread. So when you hear people talking about the digital thread, they're talking about that transfer of information and data from the real object into the simulated digital twin. And I did come across this paper this week on the digital twin in a quarry. You know, this quarry had used drones to map out the quarry using ground penetrating radar. So they had flown over the quarry with these drones. They had gathered the data from the ground penetrating radar. They had then plotted that result. So they then had a 3D image of the quarry, and then that helped them decide on areas for potential quarry exploration in the future. So they had produced a digital twin of their quarry by mapping it using drones and ground penetrating radar. This paper was just published a few months ago. So an interesting example of a digital twin of a working quarry. And I've put some good resources in there on digital twins. One is on the, both from the EU programme. One is for DigiBrain project. There's an EU programme that gives small and medium enterprises access to digital twin technology. And the second one here is a second excellent resource on digital twins, again from the EU, is the iBecome project. It helps create digital twins to optimize energy efficiency of buildings. So I've put both of these links in the PowerPoint today. So they're both well worth a look to get more information and some access to digital twin technology. So we are going to do a quick Mentimeter poll, then we'll move on to our guest speaker today. So we'll move on quite quickly because I'm a little bit late. So I'm going to ask you one question in Mentimeter this week. Do you or your organization utilize or plan to utilize in the near future digital twins, cobots, decentralized decision-making, or none of these? So just pick one area. What one would you answer to? Do you or your organization plan to utilize in the near future? If it's none of these, put none. If the digital twins are a hot topic, put digital twins, so on for cobots and decentralized decision-making. So when you go to your Mentimeter, just scroll down, see the options, and scroll to the very bottom and hit submit. So your code this week for Mentimeter, which you should have open at www.menti.com, is 66497159. 66497159. So maybe Dara, you could put that code into chat. So I'll just give you a minute or so to complete the survey, then we'll have a quick look at the results. So you can just take a quick comfort break. Then after we've seen our Mentimeter results, we'll quickly move on to our talk on augmented and virtual reality. So we'll just resume in 1 minute. So the time is 14:34. We'll begin at 14:35. Okay, I'll just share now and we can see our results from our survey. So here's what we've got in. So 43% of us are interested in, are going to be applying digital twins in the near future. 29% are looking at decentralized decision-making. 14% of us are looking at introducing cobots into our factories or enterprises, and 14% are not looking at any of these three things that we spoke about today. So interesting, seeing a large interest in the world of digital twins within our network. So I'll stop share and I'll go back to my PowerPoint, share again.
Very interesting digital twin coming top of the list there, Billy. Perhaps what we'd have expected.
Yeah, it was interesting. Yeah. Okay, so I will now move on. We looked at our data there. And so our guest speaker today is Mr. James Corbett. He's co-founder of Sim Virtua Limited, virtual reality production studio. So I've run a little bit over here, so I'll just go over to James, and James will give us a short presentation on virtual and augmented reality. Then I think you have some questions for James, Paul. Then we'll see if there's any questions from the audience in the chat box. So I'll stop sharing, and welcome to the meeting, James, and you can share your presentation.
Yep. Thanks, James. Thanks for joining us.
You're very welcome, Paul, and thank you. And thank you, Billy, as well. That was a really interesting presentation. And I think some of what I'm covering here will kind of connect with what you had there as well. So I think, are you guys seeing my presentation now?
Not yet. It can take a second to come up.
Okay. Let me try that again. So share screen 2.
Yep, that's it now.
And in full screen, Billy, yeah?
That's in full screen, yep.
Great, okay. Thanks for bearing with me there. So hello again, everyone. And it's really nice to have this opportunity to talk to you today. As Billy says, about augmented and virtual reality. So my company, Sim Virtua, we work mainly with clients in manufacturing and pharmaceutical to help them to develop and deploy solutions in augmented and virtual reality. And that's mainly in these 5 categories here. There might be a bit of overlap, but mainly it is 5 categories. And we probably won't touch on the final 2 here today, which is just as well, because Billy's done a really great job of covering digital twin there. But we will talk about remote assistance, or advisor, or even expert, as it's sometimes called. And the other side of the coin to that then is digital work instructions, or augmented SOPs, or standard operating procedures. And then the combination of augmented reality and IoT, or live data, layered and presented into your real world environment through augmented reality. So I guess if we start off at the most basic end of the spectrum, you could argue that it's not even what can properly be called augmented reality, and is maybe better called assisted reality. And the reason for that is that truly to be called augmented reality, you need to create some kind of an illusion of this digital object or information being actually in your real world. And with a headset like the RealWear that we see here, the RealWear HMT, which stands for head-mounted tablet, it doesn't even pretend to do that. It has a micro display a few inches from your eye, so it's at the periphery of your vision, and what it feels like is a kind of a handheld tablet at 7-inch tablet at arm's length from your eye, because of the optics in the micro display there. But it's a really robust device. It's got a great camera. It's self-contained. It can be used in dangerous industrial environments. I think up to 95 decibels noise it can deal with in terms of interpreting voice commands. And that's really a key to this device, is that it really excels at operating through voice commands alone. You can also control it via head mouse, which means you just move your head around and control a cursor on the screen that way. But it's made to be operated hands-free. And as a result of this, I'm not overextending or trying to do something super sophisticated. These headsets are actually selling extremely well, especially through COVID now. I think that they've done extremely well in terms of the way that this technology is being rolled out and adopted en masse now because of the fact that people can't travel so freely. So that's the hardware. And of course, because this hardware is selling extremely well, it means most of the software companies in this space make their software compatible with the RealWear HMT. One of them being Microsoft Teams is what you see in use here. So the remote expert is on the left-hand side, and that's the view that they're getting through the camera of the technician wearing the headset. And they can take their Surface tablet pen and then draw on the screen to annotate, as we see in the next slide here, to annotate what the technician is seeing, to give them a much better and more concise instruction than they can do through a lot of words. And again, this is kind of something like you'd see on, I guess, you know, a sports replay on TV called telestration, the same idea of annotating either a still image of what that person is seeing or sometimes the live video feed itself. This then is an image of what the technician is seeing through the headset. And it's because you have a kind of a limited library of commands that you can control the headset with, is the reason it can work very, very well at interpreting your voice in a noisy environment, because it's not trying to understand anything that you might say, like Google Assistant is. It knows that you're trying to say one of these commands that you're looking at. So Microsoft, certainly not the only company operating in this space. A lot of really good software here, and I'm delighted to say from some Irish companies as well, including Utility AR that you see here, Dublin-based company. Patrick Liddy is the CEO there. But the headset that you see Patrick wearing here is the Epson Moverio. So there are more headsets than the RealWear, certainly. And this is kind of the next step up in terms of sophistication, because as you can see here, it's got two translucent lenses that you can look through. So it can project the graphics into your real world in a way, whereas with the RealWear headset, you were really just looking at a solid display on the periphery of your vision. But at the same time, the graphics you're seeing with this headset, it's more of a head-up display in the sense that the graphics will move around as you move your head. So they're not kind of creating the illusion of being anchored in your real world environment, but they are kind of floating in front of you. One possible disadvantage of this headset is, as you can see, it has a tether, it has a cable going down to an external Android computer, a device to power the graphics. And this is one of the challenges with this form factor, this type of headset at the moment, is how do you deliver good enough graphics without delivering too much heat? As you know, there's a lot of heat usually associated with graphics processors, and without creating too much weight on the headset. And that's the kind of trade-off that a lot of these companies are kind of trying to figure out at this stage. Nevertheless, as I said, being deployed at scale because they're just so practical now. They really work and they really offer a lot of value, especially, as I say, through COVID. So one case study here, and going back to the RealWear headset, is a Ford Motor Company found that they had massive savings. In fact, an awful lot of the automotive industry has been adopting these technologies. Also with RealWear, big rollouts with, I think, the likes of Colgate, Coca-Cola, Big Oil, the Chinese state utility, electricity, I think, has deployed them as well. But again, automotive in particular. So Volkswagen here say that they have made huge savings in terms of efficiencies and money saved, and also downtime avoided. So we've seen the most basic type of headset, a kind of a step up from that, but certainly the most sophisticated type of augmented reality headset that's on the market at the moment is no doubt the Microsoft headset called the HoloLens. And as you can guess from the name, it's probably at that level of graphics where it's something that we would consider to be a hologram. Now, you can argue whether it's technically a hologram or not, but I think, you know, it's something that we all understand. And that, I guess, what a hologram has that the other headsets don't deliver is this creates this convincing illusion that this three-dimensional digital information is actually anchored in your real world. It's kind of stuck to a surface, a wall or a desk, and even when you move around, it stays in that position. So it delivers a really convincing illusion that it's there. So for example, you can use it very effectively for digital work instructions because of that. So we've talked about remote assistance. The other side of the coin, usually these software platforms and suites do both remote assistance and digital work instructions, where the digital work instructions is self-serve of your standard operating procedures, your SOPs, converted into digital format, obviously. So just because we're able to observe things in 3 dimensions doesn't mean, of course, that we have to convert everything to 3D. It still makes sense to present traditional media through 2D floating in the 3D. So we have a video up here on the left-hand side, we have text instructions, and then we can take advantage of the 3D as well by drawing a line directly down to that nut that needs to be tightened here, or whatever the operator is doing here. And even as she moves around, that line stays connected to that nut or bolt or whatever it's pointing at. Again, because it's a spatially oriented instruction. And even more sophisticated, we can have 3D objects that are animated in that environment. Again, as she moves around, that animation stays exactly where it is. That torque wrench is aligned exactly with that nut that needs to be tightened. So we're now on to the second generation of the HoloLens, and it's a big improvement on the first. And they've even got an industrial edition now, which is much more suitable for industrial environments, and especially for clean rooms. These headsets are now intrinsically safe. They have certifications, and they're suitable for that type of environment now. So we've seen remote assistance, digital work instructions, and for the most part, these digital work instructions on these software platforms at the moment are created, they're authored back on the laptop or the desktop, where they're edited together like a video might be. But wouldn't it be great if we could actually author and create these digital work instructions in place out on the shop floor, and take advantage of the extra accuracy that is to be gained by making sure that everything actually lines up with the real world and we're not making mistakes when we're back in the office on the desktop? Well, there are software programs that are starting to address that now, and one of them is Euphoria Expert Capture from a company called PTC, which of course is very big in the IoT space as well. And this is a really, really interesting and impressive product, and I think it helps to address some of this issue around the leakage of tacit knowledge, where people can easily capture the knowledge that they have out on the shop floor in place, and get really accurate digital work instructions. So the final use case that we're looking at in terms of augmented reality today is the combination of these headsets with your IoT data or your sensor data, your live data coming off the shop floor, coming off equipment, and being able to present that as a hologram in the context of where it actually is or where it should be. So at the right time, in the right place, in context, so we're not overpowering people with information. We're not causing cognitive overload here. That's one of the advantages, certainly, by combining AR and IoT, that we can have these digital holographic gauges, if you will, that present the right information at the right time. So one engineering company, a very big company called Howden, I think they're in 26 countries, 6,000 employees or something like that. And they've deployed this at scale, I believe, and they're gaining insights into real-time status of equipment such as bearing pressure readings, oil temperature, gear vibrations, and air temperature. And they say that when a product becomes smart and connected, you can monitor it, control it, and optimize it. It's as simple as that. This is the advantage of this software and hardware combination, and they really think it's great. Just in finishing, then I just want to pull up a slide to, I guess, give a nod to a very interesting company that sadly is no longer with us because they failed a couple of years ago. But Daiquiri was way ahead in some regards. I think they're a Boston company, but they had a big engineering team in Dublin and developed really interesting technology and had all this kind of software and hardware solution in place a few years ago. So I think you can look to see a lot of interesting startups and companies evolving out of the people who worked with Daiquiri in Dublin a few years ago. So that's it for my presentation. I hope that's being of interest and used to you. And I guess if there's time, I'd like to take some questions.
I think, Paul, you have some questions for Dara. We've maybe got a few minutes to take some questions.
Yes, James, thanks for that. That's very insightful. Again, lots of good information. I hope it sort of explains things to people. But what are the challenges you see in the adoption of these technologies to actually get them into the manufacturing environment?
Yeah, I suppose you could break down the challenges, Paul, maybe into two categories, into the technical challenge and the people challenge. You know, as Billy was talking about a while ago, you know, that issue around change management and adoption. You know, sometimes you're talking to people who are full of enthusiasm for the technology and they get it, but they might not be the right people or might not be empowered to make the changes happen. So, you know, how do you get the leadership to see the value and to drive the change? And managing the change around work practices then is certainly a big challenge that we wouldn't have seen, you know, being a technical company by background. We wouldn't have maybe seen that before we started working with more of these companies. In terms of the technical challenge, I think a lot of it that we've seen will be around the actual getting the good 3D models to work with in the first place. If it's spatial data, spatial holograms that you're going to present, you need to have good 3D information. So if you can get, you know, good BIM information, it depends on the age of the facility. Often, do we have good CAD models, good BIM information to get the 3D model of the facility in place, but also do we have 3D models of the equipment? And can we get it from the manufacturers? You know, they're often quite, they don't really want to give out often that kind of engineering information, but we don't necessarily want the engineering diagrams. We maybe just want the surface diagram, depending on the kind of equipment that we want to represent in the virtual or augmented reality. So I guess, you know, they'd be the two main challenges. Paul.
Yeah, I know in the automotive world, and they use SolidWorks and CATIA, and lots of the step files for, to say, all the robots from KUKA and ABB, and even their movements are all fully available, and you know, all 6-axis. But but how do you think things are evolving? Things are always moving, but you know, what's next? We're seeing this already augmented reality move, the technology of virtual reality, and you know, where's spatial computing coming into things? Is that something you're seeing coming soon?
Yeah, you know, in some ways there's huge publicity at the moment, isn't there, in the last few weeks around the metaverse. You know, is Facebook talking about it, and suddenly it's in the news. Everyone is talking about the metaverse, and you know, this combination of augmented and virtual reality in the cloud, or the AR cloud, which is, you know, essentially the 3D map of the world. But it's easy to get kind of carried away what's coming down the line in terms of 5 or 10 years. But if we just focus maybe more on what's happening in the next couple of years, you're seeing Microsoft announce this year Microsoft Mesh. So that's their platform now to literally mesh together this vision that they have for augmented reality and virtual reality. And if you go onto the website for that, you'll see an interesting image of, you know, colleagues who are remote from each other, and also some of them physically on the shop floor. And the guys on the shop floor are seeing avatars in augmented reality of their colleagues, and the colleagues who are remote are in virtual reality and seeing the remote colleagues from the other side. And then they're all working on, I think, a car or a model of something together as if they're physically in the same place. So it's that like dissolution of distance, I think is one of the big things that the likes of the Microsoft Mesh platform is going to bring about. And then the other one is definitely 5G. There's a lot of talk, of course, about 5G, but 5G is hugely relevant to augmented reality because, as I say, one of the big challenges with these headsets is getting that form factor down to an acceptable, essentially it should be a pair of glasses like what I'm wearing, so that people will be comfortable wearing it. It's not too hot, it's not too heavy if you want to wear it all day. But how do you do that when you've got this massive graphics processing challenge? Well, if we can take advantage of 5G and have our graphics processed in the cloud on the edge and delivered in with low latency quickly to the headset, then we can actually bring the form factor down to this comfortable format, and at the same time not have this issue of nausea, which is what's sometimes experienced in AR and VR when you have this mismatch between, when you move your head and if the graphics don't align quickly enough, that tends to cause motion sickness. So if you have a lag or a latency, you're going to have that issue. But with 5G, there's the real promise now that we won't have that kind of latency.
I think they're great inputs there, James. We're going to be running out of time here, Paul. So, Dara, maybe you could take one question from chat for James.
I think Paul was answering questions in chat there as we were going. So okay. I think we're all good here if you want to continue on, Billy.
Okay, James, if you want to stop your screen share, I'll take control and I'll just conclude the session in the last few moments here.
Thanks a lot, James. Fantastic. Could I just say before, if people could respond to the feedback survey to see how we can improve things, but thanks to everyone again, and I'll leave you with Billy to close up. Thank you, Dara, James, and Billy.
Thanks, guys.
So today we spoke about, we've done a module 1 recap. We looked over what we spoke about last week. We spoke about key concept number 3, Cobots. We spoke about key concept number 4, decentralized decision making. And we spoke about one of our tools in our Industry 4.0 toolbox, the digital twin. We done our little Mentimeter survey, and we found that digital twins are quite popular. Lots of people are looking to introduce digital twins into their facilities in the now or in the very near future. And we had a really interesting talk there on augmented and virtual reality and what's happening there from James. So that was last week's whiteboard work. I'll add this week's whiteboard work to this slide. So as we build through the 3 webinars, we'll have a good summary of what we've done in the whiteboard. And call to action this week is assess your organization for its adoption of cobots and decentralized decision making. How are you doing? List your cobot and decentralized decision making examples. What are you doing in the world space of cobots and decentralized decision making? Recognize the good work that you are doing. Look for high cost areas in your organization where they could be applied. Is there areas where cobots would be helpful? Is there areas where your decision making could be streamlined and employee empowerment could be enhanced? And think, what are your competitors doing? What are they doing about cobots and decision making? Do employees in your competitors have more autonomy? Are your competitors using cobots already? And if so, where? Find that information out. So I'll close with a quote. This is from Dilip George, artificial intelligence neuroscience researcher. Imagine a robot capable of treating Ebola patients or cleaning up nuclear waste. Well, actually, we're already there. We can already do these things, so it's unbelievable. So 4-module course. Next week, webinar 3, we'll be talking about cybersecurity, additive manufacturing, big data, and super excited to have our guest speaker next week, Ian Keeney from Skellig AI. That's going to be amazing. So stay connected. I am Billy Schofield. You can connect with me on my website, billyschofield.ie. You can link with me on LinkedIn at Billy Schofield, and you can email me at billyschofield@billyschofield.ie. So thank you for attending this webinar that will be posted up on the YouTube channel. Any closing comments, Paul?
Yeah, just like to say thank everyone for joining in. And obviously on the industry4skillnet.com website, there's more information. You'll be able to see repeated webinars and information on the training courses available in the Industry 4 technology world. Thank you all for attending today and hope to see you all next week.
Okay, see you next week. Thank you. Bye.